All right, welcome back everyone. I hope you enjoyed the delicious lunch. So our first session for the afternoon here in the wastewater stream is Phil Smith from Watanbe Engineering. And the title of the presentation is Controlling, Monitoring, and Recording Level. Phil is a senior electrical technologist with over 35 years of experience. He is responsible for designing, inspecting, and commissioning electrical power controls and data telemetry systems. Phil works for Watanbe Engineering, specializing in electrical design for water, wastewater, and drainage stations in municipal and First Nation communities. Phil was the SCADA guy for the city of Chilliwack for 7 years, working as a water distribution and wastewater collections operator. Please welcome Phil.
Good afternoon, everybody. My name's Phil Smith, as was introduced, and I would call myself a bit of a level control geek. I love level, I love control, I love monitoring things, and what I've noticed over the years is there's a lot of stations out there, particularly in the wastewater industry, sewer lift stations, where we're still using kind of float-based control systems, which they have their place, but I thought it would be a good idea to kind of just get some people thinking a little bit about what the advantages of maybe moving away from that technology, some of the costs involved in that, and what it can bring, to you as a water operator or a sewer operator. So there we go. So we're going to touch on a little bit about the differences between the types of control, so switched control versus level control, analog control, sorry, and then trending. What can trending do for us, and what can we use trending for? I was going to talk about remote access. I forgot to take it off the slide, actually. Sorry. I'll touch on it just briefly at the end, talking about what we can do with remote access as well. So, switch control. So, just a show of hands, anybody that's still using float control-based systems in sewer lift stations? Okay, quite a few people. So, I'm not knocking this as a system. It's been around for many, many years, and it was the kind of go-to standard back in the day. And in some applications, it still works very well. I've been going around the province, seeing lots of different municipalities, First Nations communities, and I kind of notice a bit of a similar trend. Some of these stations are in, not the best shape, and what I tend to find is float switches, as you can see from the picture there. This is a station I was at fairly recently. They tend to be in, they're not ever so well-maintained stations, perhaps, because you don't go to look at them too often. And part of the problem with the float switch, of course, is it's in the liquid. So as you can see on the diagram at the bottom there, at least one of the float switches, the low-level switch, is always going to be in that liquid. Usually the start level switch is also going to be the stop level switch is also going to be in that liquid 100% of the time. And then the other two, the start level and the high level float switch, will be up out of the liquid, so only seeing it a few times. And part of the problem with this is, as we know, this isn't clean water, so there's a lot of stuff hanging around in there, tends to get jammed up on the floats. If you've got any grease problems, it builds up on the float switches. And recently I was actually at a community where they were having some issues with a pump, and the reason was that their float switch was actually jammed to the sidewall of the wet well in the grease, and it was permanently tipped, so the thing was running 100% of the time. So that was a little bit of a challenge. We got that cleaned up. But this is a big problem. Does anybody else experience, just show of hands again, anybody else experience problems with float switches kind of ragging up, or in the grease? There we go. So we're seeing that sort of all over the place. So now the big reason that we used to use these is that it was cheap, right? It's cheap technology. It's just a switch, and you put them in, set the level, we're good to go, right? It'll turn on, turn off. The other problem I find, and I get asked to come out and troubleshoot a lot of these stations, is when one of these float switches fail, which they do sometimes, it's very difficult sometimes to tell which one's failed. It's not always the one that's obvious. So suddenly the pumps start doing weird things, and you're not really sure why or what's happening. So they're not the easiest system to troubleshoot. And these switches are not cheap anymore. Does anybody know what a Xylem float switch costs nowadays? I think they're in the region of about $500 now, so they're not a cheap solution anymore. They used to be a little bit cheaper. So it says there they're in the liquid, and yeah, maintenance and cleaning is absolutely mandatory for these stations. So you need to be out there looking at these things on a regular basis. So that's where it comes on to the next part. So now we start looking at analog control. So a number of advantages to having some sort of analog control. I'm going to touch on the three different technologies that I've got here. There are others as well, and I'm actually going to just touch on a really old one, which I just put in there for fun. But so the downside to using some sort of analog control is you need something to take that analog level and turn it into a switch, so that it'll turn your pump on, turn your pump off. So we do need an extra piece of equipment. It does allow level, so you'll actually see, hey, I've got 1.3 meters or 0.2 meters in my wet well. So that's kind of nice to have that indication on the control panel. It's very easy to change your start and stop levels. With a float switch, I mean, who loves going down in there and changing the actual float switch level? Whereas on these, when you're using a controller, very easy to change the level by just changing some set points. You can change the start level, stop level pretty easily. We always do recommend putting in a float switch in addition to some sort of analog transmitter, just in case that transmitter fails, because, hey, it's still an electronic piece of equipment, it's going to fail. But the beauty of that is it's a high-level float switch, and it's going to be out of the liquid the whole time. It's only ever going to tip when something goes wrong. So you're not going to have that kind of ragging or greasing up problem that you have with the fully controlled float switch system. It does require regular maintenance, because there are some, depending on which technology you choose, there are some maintenance issues that you need to take care of. You can't just leave them alone, although some technologies are better than others, and we'll touch on those in a bit. And for the most part, two out of the three of these systems I'm going to talk about, the transmitter itself is out of the liquid, so high and dry as we call it, which is really nice because you have less of an issue with it getting clogged up with things. So, hands up, anybody who knows what this is? Anybody seen this? Anyway, somebody, how old are you, sir? So I'm going to show my age a little bit here. I've actually worked on one of these systems before, and I just thought it was kind of cool to touch on this. So this is the first ever analog type control system I ever worked on, and it wasn't a sewer wet well. It was actually in a waste meat collection system where they washed waste meat down into similar to a wet well, into a well in the ground, and then they measured the level of that. So basically the idea with this is that you pass air at a constant rate through a regulator down a tube into the well there, and then you measure the pressure that's at the top, and as the level goes up, the back pressure just increases, and from that you can measure levels. So horrible system, used to clog up all the time, was very inaccurate, but it was kind of cool. So this is old technology, so this is what I was used to when I was an apprentice back in the day. So I'm going to go onto the three different types of transmitters that we kind of currently see in wet wells nowadays. And this was one of my favorites for a long time. Actually, when I was in the city of Chilliwack, we had a lot of ultrasonic transmitters there, and I kind of didn't like those very much. We were having a lot of failures, so we started moving to hydrostatic pressure transmitters. And hydrostatic, there's two ways of measuring level with hydrostatic. I'm going to touch mostly on the submersible level transmitter here, but if you're in water, you can also do it where you have like a pipe off the bottom of the reservoir and measure the pressure at that point. But both technologies are the same. Ultimately, what we're measuring is the difference in the pressure from where the transmitter is to atmosphere. And the reason we have to measure differential pressure is because if atmospheric pressure rises, we get a change in our level otherwise. So we're measuring differential pressure. And on the hydrostatic one, there's a very, very tiny tube that runs up the inside of the cable and comes out at the top. And we have to use some sort of bellows. You can see the bellows there, or a desiccant that we see there. And the idea of that is to keep that tube dry, and that's our reference to atmosphere. So as atmospheric pressure increases, it uses that as a reference to get its level correct. These are good if you maintain them very well. And the bellows system, I have more success with. They tend to last longer. I've seen many, many stations where there's desiccant used, and desiccant starts to go pink when it's wet, and I've seen some of them that are almost bright red, so they're not doing their job at that point. So if you are using these systems, please change the desiccant regularly, keep an eye on them, or make sure you've got a good bellows on there. And on the slide here, there's a few different types of submersible transmitter. And they range from different applications. I've had good success with the just with this sort of torpedo 3/4 inch sort of style transmitters there. The big one with the cage on the bottom there that was really designed for sewer applications. I didn't have a lot of success with those over the years. I didn't really find them much better than the other ones. So, anybody using those type, the cage type? Yeah, a few of you. Okay. I tend to find those clog up more. They just trap the dirt more than the torpedo style ones. So, the one thing with any of these transmitters, they generally would be hanging from a cable. And again, anybody that's got grease buildup, I would kind of caution the use on these type of transmitters, because if you have grease, there's a tendency that grease will build up around the cable, and when you try to pull the transmitter out, it'll get to a certain point, and then you'll hear a donk as it hits the bottom of the wet well, and you've broken the cable, and just lost a $1,500 transmitter. I've done it a few times. So yeah, so just be cautious. Usually they need some sort of carrier tube or some sort of sleeve down. It's not really it's not a stilling tube like we would use on a say a ultrasonic transmitter, but it just stops it wandering around inside the wet well when the pumps are running. So good thing about these is they don't get affected by foaming because they're under the liquid. The foam's on the top, so we don't worry about that. They're not really affected by temperature. There is some temperature compensation inside of them, and yeah, they can get stuck in the grease there. So that's it. All right, moving on. So hands up if you've got ultrasonic. Anybody using these? Okay, so Siemens, there's lots of, we see the Siemens product up there quite a bit. This one's a Siemens transmitter that you see on the screen here. So this is one of the technologies that's high and dry out of the liquid. Very good technology, has been around for years. Part of the reason that this wasn't used, or the float switches was used over this technology, was just the cost of it. This, originally would be like $4,000 to $5,000 for the transmitter, because you need the actual sensor and the transmitter together. But now, that cost differential's changed a little bit now. So ultrasonic uses sound waves for measurement. And I don't know if anybody was in the presentation yesterday where they were talking about the flow meter with ultrasonic. So one of the cool things with ultrasonic is it's the pulses, when you pulse a sound wave, it can be affected by wind, it can be affected by humidity, temperature changes. So that technology can be used in different applications because it can get changed by various factors. But in this application, that's not an advantage to us. So a lot of the time, these transmitters or the sensors have to have some sort of temperature compensation in them. And the other thing I find, and this again just down to experience, is most of the time that I saw failures on these devices was this time of year where we get the really cold mornings, and then people are showering, you get a lot of condensation, a lot of vapor inside the wet well, and that really interferes with the signal of sound waves. So yeah, the sounds affected by that buildup of sort of steam or gases. It is affected by foaming. These tend to not punch through foam very well because it's a slightly lower frequency pulse that it's sending down to the liquid level there. So basically the way that it works is it sends out a pulse, and it looks for how long it takes to see that pulse reflection come back up, and that's how it determines the level. And then when you get into the transmitters, there's ways of telling it to ignore things in the wet well. These tend to have a very sort of wide beam angle on them, so it will pick up things on the outside edge. And if you get grease buildup, it will definitely pick up on the grease buildup. So you might have to do some what they call echo profiling to make sure it's not picking up stuff that it shouldn't do. And the last thing there is to sometimes stop it looking around the outside or picking up things on the outside of the wet well. We'll sometimes put it in a stilling tube. Because it's sound wave, if you think about like talking into a pipe, all of that energy gets transmitted down the pipe. It stays within the tube. So a stilling tube will kind of direct that echo down and then look for the reflections coming back. And that's important on the next slide. Here we go. Okay, so this is probably my favorite technology nowadays. So radar, we're starting to see this come into play a lot. And I'm not selling these, but I do have kind of some favorites out there. So this uses radio waves, which is higher frequency than the ultrasonic, so it has some advantages. But the big thing that we're finding is that the cost of these things is coming into play. You can actually put a transmitter in for less than $2,000 now, so that's very comparable to the float switch type applications. You still do need your controller to be able to control your pumps as well, so you have that little bit of extra cost in there as well. But it's becoming very comparable to a relay-based float switch system. So transmitters out of the liquid, you can set these things right at the top of the well, right out the way. So even if you get the occasional flood or high level, then they don't get affected by that. And they're not affected by humidity or temperature, the same way that ultrasonic is. So the radio waves, because they're higher frequency, they kind of just punch through all of that stuff. They don't have that same effect. Doesn't require a stilling tube. In fact, they tell you not to use one because the stilling tube effectively is useless because the higher frequency will just punch right outside of that tube. So I have put some in where we've used a tube more as a carrier for the to mount the transmitter on the top, but it will see stuff on the outside. So the tube doesn't contain that beam angle. But you can also get very tight beam angles on these of like 2 or 3 degrees as well. So they're looking at a very small area in the bottom of the wet well. Super easy to mount. They're very small, a lot of these transmitters, very self-contained. The one that you see on there is actually Bluetooth as well, so you can just sit there with your phone and configure it all with the Bluetooth on and out. Very, very easy to play with. And then the other advantage is it can actually see through non-metallic material. So if you have a composite grate, like a floor grate in your wet well, theoretically, I've never actually done this yet, but theoretically it can see straight through that grate. The one you see in the picture here is actually an aluminum grate, so we have to leave the grate lid open. This was a float-based station that we upgraded, took the floats out and put a transmitter in. So yeah, one of the things if you're doing, say, chemical work with these, I know I'm a little bit off topic here, but if you're doing chemicals, you can have a big tank, like a tote, and just mount a transmitter, slide your tote in underneath, and it will look right through the lid. The plastic doesn't affect it, so kind of useful. Oh, wrong button. There we go. So monitoring. So we talked about float-based versus analogs here, and a big reason that I like having the analog is that I like to see what's going on. I get so many people that call us up and that say, hey, got a problem with my sewer station, and we take a look at it and it's float-based control, and I'm like, well, I've got nothing to go on. I've got to come and look, do some diagnostics on site, try and figure out what's actually happening. Whereas if I had some trend data, see what's going on with the level, I can probably tell you what's happening inside your wet well. So I'm just going to go through a couple of graphs here. So anybody, hands up if you've got SCADA. Anybody got SCADA? There we go. Cool. I'd love to see that. So how often do you check? Let's do a quick poll then. How often do you look through your stations on your SCADA? So who does it every day? Yeah. Oh, good for you guys. Excellent. Like to see it. I'm teaching the wrong crowd here. How about once a week? Yeah. Okay, once a week. And how about never? We just look at it when we need it. Okay, cool. That's good. I'd like to see that. So yeah, looking at these trends can really tell you a lot of information. Like I say, I was the SCADA guy for Chilliwack for 7 years. I was working with Chilliwack for 8, but did the SCADA for 7 years. And I pretty much looked at them every single morning. And we had 56 lift stations, I think it was. So I got really good. They kind of all they had their own personalities in the end. I could tell which one wasn't working well, based on its trends. So we're just going to go through a few things here in terms of what we see in here. So we get a nice long run here. You can see a nice steady climb. So this is like early hours of the morning, and then we kind of move into more of the day here where we're getting the closer pump runs. So this is kind of typical. One of the things you'll see though, if you get rainy day, all of a sudden these get really tight. They start to become really quick pump cycles and quick fill times. So that's a good indicator if you're, if you've got I&I in your stations. You won't see that necessarily on your float-based station. Now, I know operators were really good at looking at the hour meters on our pumps and writing them down and analyzing that data to a certain degree, but that's not going to tell you the data as quickly as this is. You know, if you've got some problems with your pumps, it might be 2 or 3 days or even a couple of weeks before you start noticing the trend differences. So this is kind of a happy pump system. So we've got pump number 1, pump number 2, and we can see that the actual pump cycle is pretty much the same for the 2 pumps here. So, you know, steady incline, same sort of decline for both pumps. But then if we look at this station, this one is straight away telling me that we've got some sort of issue with one of our pumps. So we notice that the red pump here has got a short cycle time, and then the green one's got a longer cycle time. So this could probably be due to some ragging in the pump. And I'm sure most of you have figured out that just because the pump's got rags in it doesn't mean to say it's going to trip out. It's going to keep running, wear out your wear rings really quickly. So if you're relying on your hour meters, you might be running this pump for a couple of weeks before you actually notice any significant difference in the pump run times. Whereas if you look at this screen, you can see it instantly. So the other thing this is going to tell us, of course, is engineers love data. One of the things they're going to look at, particularly on water systems, but also on sewer systems, is, hey, you need an upgrade, but how much flow have you got? You know, what are your peak demands? What time of day is your peak demand? Do you have any I&I issues? And, you know, what's your peak demand on those times? All of this information, if you're trending it, you pass those over to the engineers. They do work some magic, and then they can figure out what it is you need for pump upgrades and changes in your system to make things better. So lastly, I was going to talk about, sort of touch on, how much time have I got here? Probably lots, eh? I think I'm a little ahead of time. So I was said to touch on just remote stuff as well. So with some of these controllers, particularly one of the radar ones that we use on a regular basis, you have the radar transmitter and then a controller that controls the pumps. One of them that we use has Ethernet built into it. So I was going to try and do a demo. It didn't really work out. But with that Ethernet, we hook it up to a radio, cellular, you know, direct radio, whatever we need to do. Could even be, you know, Starlink. And now me sitting in Chilliwack at my desk, I can actually dial into the controller and then get communication path all the way through the cable to the transmitter that's in the wet well, and I can do an echo profile remotely. And actually, I was in my hotel room last night doing exactly that. Anybody know where Kinkham Inlet is? I just put a radar transmitter and reservoir there, and I had to do a quick echo profile on it. So, you know, it's like 3 days for me to get there and back. So being able to do this stuff remotely is huge. And I get all of that data. We're capturing all that data, keeping it all, and I can keep an eye on the reservoir, or if it was a sewer station remotely. If they were having issues, they just call me up. I take a look at the trends, see what's going on. So yeah, think about remote stuff. If you haven't got SCADA, I seriously recommend you start thinking down that route. So data's worth a lot of money. Cool. I'm pretty way ahead of time here. I'm going to let you guys are going to have a great break. All right, so has anybody got any questions? Feel free. Let's have some discussion here. Cool.
Have you found any problem with radar next to seaways, or we had an issue with a radar type device, and when the big yachts went by, it was disrupting the radar?
Okay, I haven't seen that. Do you know what type of radar it was?
We just took it out.
Oh, okay.
Went back to a float switch.
How old is it? Like, how long ago are we talking?
This was 3 years ago.
Okay, yeah. So sometimes that's so some of the transmitters are a little different. So the one that we use is generally it's all built into one transmitter. It's got the antenna on the bottom of it. It's all built into the same unit. But if you're starting to get issues with those, I would go back to the manufacturer and take a look, because you can get into more specialized applications with radar. And again, the cost might be prohibitive in this case, depends on your application. But you can put different radar antennas on the bottom of them. They get the big cone ones, and they can start tuning out some of that kind of false frequency stuff like that. So yeah, I mean, when I say that these are cheap, then yeah, there's a whole bunch of them that are off the shelf. They put them in, they work great, they're cheap. But yeah, if you run into a more complex system like that or a problem like that, you might have to look a bit deeper. But that might be a good solution for like a submersible level transmitter, right? So, you know, again, depending on the condition of your wet well. Yeah, it's not one doesn't fix all, so for sure.
Any other questions in the room?
Cool.
Oh,
Yeah, we got a few of the obviously radar systems on some of our drainage stations, and I guess one of the annoyances that we have is we can get a cobweb and that pump will kick in, or it'll
Yeah.
read the ice when it's cold in the winter. Is there any way to like mitigate that from happening, or is it just
yeah, that
nature of the beast?
Yeah, that is a bit of nature of the beast, and it doesn't really matter which of the technology is using, whether you use an ultrasonic or radar. They both suffer with that. The radar was even worse because it often had the big cone over it, and then the spiders would build their web right underneath, and you'd see it running backwards and forwards, and yeah, cause you complete chaos. But yeah, just the only thing would be like wherever you put it, just think about where it's going to be, and then maintenance. So yeah, there's not a perfect solution to that, unfortunately. You could try putting it in a tube. I mean, that might be another solution. So you put a cap on the top and then just bury it into the cap and have a tube, so you've probably got less likely for stuff to be underneath there. If it's in the wide open air, then obviously spiders are going to be around there for sure. But yeah, the tube won't affect it, so it just really just stopping the stuff getting on the top of it there. Yeah. Does that answer the question? Yeah.
nothing online?
Cool.
Wonderful. Thank you very much, Phil.
Thank you, guys.